Just 630-670. 630-67084. Only you. More than 93 persons are already on.
Hey.
Good morning, everyone.
Morning, sir.
Morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
I hope you guys
Good
are doing
morning,
well.
sir.
So
Thank
Hi,
you.
sir.
Good morning,
I'm
sir.
just waiting for more students to join.
Morning, sir.
So I hope you all received the material I sent.
Yes, sir.
So we are
Yes,
still
sir.
using okay. So let's just hold on for a while and then we start. Okay. Once again, good morning to you all.
Good morning, sir.
You're welcome to FBA 310. FBA 310 is a continuation of FBA 220. So that means the course title is Business Statistics 2. FBA 220 is largely descriptive statistics, where we have been introduced to various methods of data collection and data summary. Then we were told that after collecting your data, you can summarize your data using tables, graphs, and other charts. You can also summarize your data using numerical summaries, either with the use of measures of location or with the use of measures of dispersion. So under the measures of location, we discussed the use of the mean, median, mode to describe the concentration of our data. And the measures of dispersion, we discussed the use of range, mean deviation, variance, standard deviation, and the like. Those figures gives us an indication of how spread our data is. But in 310, we'll be looking at inference, how you can take a decision based on the data that you have. So how do you generalize? How do you test for the truthfulness of a claim? So that is what FBA 310 is about. So my name is Ismail Adeleke. I'm from the Department of Actuarial Science and Insurance. I will be coordinating the course, but Dr. Ajijola will largely do most of the work. Teaching along with me include Dr. Ajijola, Dr. Shogunro, Mrs. Patrick, and also Mr. Orwell. So together we will make sure that as much as we can, ensure that you understand the basic concept that we'll be introducing. The textbook that was shared during FBA 220 class still stands. However, we have also prepared some questions and an answer for you so that you can practice more. Dr. Ajijola will be giving you further information on that so that when you get your hand dirty by solving so many questions, you'll be ready to do very well in the exam. It's a very simple course, and I want to assure you that our records of having so many A's, will continue, but provided you are ready to work for it, and nobody is dashing marks. But we will create the platform for you to excel. So for the assessment, we'll be giving you regular assignments. We'll also fix a date when we'll have our continuous assessment, test, which will combine with the regular assignments that we've been giving you to make up about 40% or 30%, depending on what we agreed at the end of the day. So that means your exam could be 60% or 70%. So I also want to assure you that we are here to cooperate with you and also ensure that you have the best of experience. So materials will be made available to you from time to time. And also feel free during lecture period to express your mind. You can ask questions, you can make comments, you can file complaints. You can also raise observations if you have any, so that at the end of the day, we all have good experience in the course. So like I said, it's a very simple course, and I want the best for you. So I'm starting with sampling and sampling distribution. Sampling and sampling distribution. So what exactly will we be looking at? I'll be looking at key definitions. We'll look at what sampling is. Although in FBA 220, we have covered a lot of grounds in that. But we will just do a quick recap of what sampling is and different types of sampling techniques that we have. We will also be looking at some basic definitions. What is population as far as VA 310 is concerned? What is sample? What is statistics? What's estimation? What are estimates? What is sampling? What's sampling frame? And then we will now go into the business of sampling distribution. So as a recap, from what we did in LBA 220, we were introduced to the term population. So as far as we are concerned, population simply means collection. So when you put together the constituent of a well-defined object, it's like your set theory, the set that you did in SS3, GSS3. You were taught that a set is a collection of well-defined objects. So you can have a set of chairs, you can have a set of schools, you can have a set of companies, you can have a set of books, and so on. So that's similar to how population is defined. So population here is a collection. So when you put together well-defined objects in a defined space, what you have is the population. Population is different from population size. So when you count the number of units in that population, then you have population size. So population can be finite and it can be infinite. So let's look at the entire blood in you. The entire blood is the population. So if you take a little part of it, you know that what you have here is the sample, all right? So when you collect all the blood, all is the key word there. When you collect all the blood together, what you have there is the population. Okay. So you can also have population of human beings. Okay. What's the population of Nigeria? Population of Nigeria is made up of people from diverse backgrounds. That's the population of Nigeria. But if you're not looking at the population size, then you can say, oh, we are about 200,000, 200 million, 214 million, 118 million, depending on the source that you are getting your figure from. So the population size is the number of units in that population, while population is the collection, okay, of all the units of a specified type in a target universe. Okay, collection of all the units of a specified type in a target universe. That's what population is. When you put together, okay, well-defined units, what you have is the population. But when you decide to count the number of units in that population, then what you have is the population size. But however, a sample is a fractional part of a population, the subset of a population. So going by the example I gave earlier on the blood in an individual, the entire blood in that individual is the population. So if you go for a lab test and there's need for blood tests, to check whether you have some malaria parasite or other unwanted elements in your blood, then there's need for a sample of the blood. Sample. That means a subset of the blood, a fractional part of the blood. So a sample is the fractional part of a population. Remember that population is the collection. When you put together, okay, all the units, you have the population. If you decide to count the number of units in that population, what you have is the population size. And then the sample is the fractional part of the population. So what do you do with the sample? Because at the end of the day, you wanted to take you want to make an inference about that population. You want to have an understanding of the population. So that means the essence is to estimate. You want to estimate some parameter of interest. Why is the lab technician taking the sample of your blood? They want to ascertain whether there's malaria parasite, or whether there are some other elements of sampling too. You want something. You want to have an understanding of the entire population. It's not feasible most times for you to study the entire population. Because someone is sick and you want to determine whether that person has malaria parasite or not in his blood, do you need to suck the whole blood dry because you want to test? No, it's not feasible. So you just take a little drop and then you observe, and whatever you see in that drop, you generalize on the body. So that's exactly what we do when you take sample from a population. You are about finishing cooking and you want to check whether or not your sauce is right. You know, you don't have to consume the entire soup because of what you are testing. So what will you do? You just take a little part of the food and then you taste. Based on your judgment on that little part that you have tasted, you just make a judgment. Then you generalize that, look, I think there's need to add more salt. I think there's need to add more water, and so on. So that's the essence of a sample. So we say population is the collection, okay, of all the units specified type in the target universe, and sample is a fractional part of a population or a subset of a population. And I said the whole essence is for you to estimate. Okay, so you are trying to calculate something. You're trying to have an understanding of that population. Right? So any function that represents the entire population is called a parameter. Parameter. So a parameter is a function of all the units in a population. So I can have the population mean. That means what is the average age of students in a VA 310 class? What's the average age? So that means I'm interested in the average age of the students. But I know I can't get all the students at a time. So I can decide to take sample of the students and then get their age. And then what do I do with the age? I will calculate the average. So that average age of the sample will now be inputted as the average of the population, because I'm using the sample to estimate for the population. So that function that represents all the population is called parameter. Parameter. So I can have population mean, I can have population variance, I can have population standard deviation. As long as that function represents the entire population, is simply known as parameter. We'll be making use of this term as we move on in FVA 310. But however, we also have function that represents the sample, not the population this time around. So parameter goes with the population. But what goes with sample? It is statistic. Statistic goes with sample. So I can have sample mean. I can have sample variance. I can have sample proportion. All right. So as long as they represent the units in a sample, they are referred to as statistic. Singular, one of them is statistic. So when I put many of them together, they are referred to as statistics. So statistics here is different from the course. It's different from the discipline. It's different from the body of knowledge. It just represents function of sample. So far, we have looked at population. We said population is the collection, okay? Collection or the aggregate of all units of a specified type in a target universe. Population is not the counting. No. Population size is now the counting. So I have described the population of FBA 310 class. What's the population? The population of FBA 310 is made up of 300 level students from accounting, actuarial science, insurance, finance, ER and HRM, and possibly from business education. That's the population. But if I now ask about the population size, then I can ask the governor, oh, what is the size of the population? The governor can just say, I think in our class we are about 200. Some other governor can say, I think we are 180. So altogether, if I added, I will now have the population size, right? Then sample. So we say sample is a subset of a population. So we don't know what a subset is. Part of. Okay? Part of. So it's a fractional part of a population. So why do you take sample? Remember, I said we take sample so that we'll be able to calculate, we'll be able to estimate the population parameter. And most times, this population parameter, they are unknown. If they are known, there's no need for you to take sample. Somebody has imported bulbs. The bulb is assumed to be environmental friendly. That's what the importer claims. But there's a regulator, SON, that we need to confirm if truly those bulbs are environmental friendly. The regulator will require sample of the bulb to test. What are they trying to do with the sample? They want to have an idea of the quality of the bulbs that is being imported. You see, if the details of the population is known, if they are so sure that the quality of this bulb is good enough for us to consume, then there won't be any need for them to request for sample because they are sure. But because they are not sure, they request for sample. That sample will be used to estimate the population parameter. What is the parameter? They check maybe the lead level, they check maybe the gaseous content, they check other things. It could also be the lifespan of the bulb, the breaking strength of the bulb, and so on. So those are the parameters they want to check whether it meets minimum standard or not. So the essence of taking samples is to estimate the population parameter. And most times, these population parameters are unknown, right? So, and then I defined what a parameter is. I said a parameter is a function of all the units in the population. Okay? A function that represents the entire population. Population mean. It represents population because it is the average of that population. Population variance, population proportion, and so on. So those are examples of parameter. The parameter is a function of all the units in the population. However, we also have statistics. Okay, so a statistic is a function of all the units in a sample. Right, and then when you have so many of them, more than one statistic, we have statistics. Remember, the statistic we are talking about here is not a subject, is not a body of knowledge, is not a discipline, it's just simply formulas, right? Functions. So the next term that we'll be looking at is estimation. I've mentioned this term several times. Estimation, right? Estimation. So estimation is the procedure, okay? The procedure for calculating the value of the parameter. That's estimation, right? Estimation is the procedure for calculating the value of the population parameter. So how do you calculate the value for population parameter? Remember, you take sample. After taking sample, then the sample will be subjected to some tests using various techniques. And then those tests, those various techniques will generate figures. And then the figures you plug into various formulas, and then you arrive at your results. All those steps, collecting data, subjecting them to tests, generating figure, calculating, and so on, they are referred to as estimation. Estimation. So estimation is the procedure for calculating the value of the unknown population parameter. Now, after the whole process, we arrive at a figure, right? We arrive at a value. So that value that you arrived at is called the estimate. The value that you arrive at is called the estimate. So we have gone to the lab technician, and the lab technician have taken 2-3 drops of your blood. They observed it, and then they said certain element is maybe one per certain unit. So that means they have calculated, and then they arrived at the result. That result is the estimate. Okay, so that result is the estimate. I'm interested in your average age. Maybe I have a product that I feel might be good for you, but I wanted to be sure that you are within the age bracket that the product is meant for. So I can decide to just get sample of your ages, and then I compute. So if I arrived at maybe 19, for instance, 19 years as the average age, so what I have there is the estimate, all right? The estimate. The whole procedure that I went through to arrive at that 19 is estimation. So what I arrived at is the estimate. Okay, so, and then we also have estimator. Estimator. Estimator is simply a formula. You know, it's different from the procedure now, because the formula is part of the procedure. But the exact formula that you use is the estimator. So if I want to estimate the population parameter, maybe mu, the mean, population mean. So the estimator, the formula for it is x bar, summation x all over n. That means it's the formula, the estimator for the population mean. So there are so many formulas. So we have x bar, we have s, which is the square root of summation x minus x bar squared all over n minus 1. That is used to estimate sigma. So we also have p hat, which is x all over n, where x is the number of elements, number of units that fall within the category of interest, and your small n might be the sample size. So various formulas that are used in calculating the parameter, they are the estimator. Now, estimation can be divided into two. We have what we call the point estimation and we also have interval estimation. Point estimation and interval estimation. You know, there are times that you calculate for a parameter and then you arrive at a single figure. So it's possible for me to say that the average lifespan of this bulb that have been imported is 2 years. So I'm being definite. So I'm arriving at a single figure. But it's also possible that I can say that the average lifespan of this bulb is between 2 years and 5 years. So in the first instance, I'm definite about the lifespan. But in the second instance, I'm giving possibilities that, look, it could be any value in between this interval. So if you calculate and you arrive at a single figure, the procedure that led you to that single figure is called point estimation. Point estimation. But on the other hand, if you have used a procedure that led you to an interval, a range of values, such that you can say that the minimum is 25, the maximum is 80. So that means you're saying that the average or whatever you have computed should be in between 25 and 80. So in that case, the procedure that led you to that kind of value is interval estimation. Interval estimation. So our estimation can be point and it can be interval. So let's just do a quick recap of what we have done so far. I started by explaining population. So I said, as far as we're concerned, that the population is the collection of well-defined objects, or you can simply say that this is the aggregate of all the units of all specified units in a target universe. So that means whatever you are putting together must be well-defined, just as you define your set. Then I also define sample. A sample is a fractional part of a population, a subset of a population. So what do you do with your sample? Most times we want to use the sample to have an understanding of the population. That is, you use the sample to estimate, to calculate the population parameter. So we define parameter. Parameter as a function of all the units in a population. So you can have population mean, you can have population variance, you can have population standard deviation, you can have population proportion, and so on. So as long as that function represents the entire population, what you have is the parameter. Then we discuss statistics. We said a statistic is a function of the units in a sample. So your sample mean, your sample standard deviation, your sample proportion, they are your statistics. Okay? So, and then we also looked at estimation. So we said estimation is a procedure that you go through for you to estimate or for you to calculate the value of the unknown population parameter. And I explained to you why population parameters are usually unknown. Because if they are known, there's no need for you to take sample because you have full understanding of the population. Why will you take a spoon of your rice, when you are about concluding cooking? It's because you don't have full information about the pot of rice that you are cooking. You want to be sure that the sauce that you have added is right. So because you are not sure, you don't have complete information. That's why you need to take sample. The lab technician is not sure. Mere looking at you wouldn't be able to determine whether you have malaria parasite or not. So there's need for them to take 1 or 2 drops of blood from you, and then they observe. So it's the same thing. The SON is not sure of the product. It's not sure of the quality of the product that is being brought in, and that's why there is need for them to test. If they are sure, they have the complete information, then there is no need for them to take sample or test. So that's the essence of a sample. You want to have an understanding of that population. So the procedure for calculating that is estimation. So we said that procedure could lead you to a single value or it could lead you to a range of values. If it leads you to a single value, what you have done is point estimation. Otherwise, if it leads you to a range of value, what you have done is interval estimation. Now, the value that you arrived at is called the estimate. The estimate, the value that you arrived at is called the estimate. So again, you can have 2 types. You can have point estimate, you can have interval estimate. If you arrive at a single value, what you have is point estimate. If you arrive at a range of value, what you arrived at is interval estimate. And then the formula that you used, those formulas, they are referred to as estimator. So if the formula will lead to a single value, that means that formula is point estimator. Otherwise, if it leads you to a range of value, that formula is interval estimator. So you will agree with me that this course is a very simple course. It's just the way I've been explaining it, and it's going to be very, very interesting and very, very applicable. Everybody does sampling. Everybody. So even you, in your own personal space, you do sampling. You want to take decision. It's expensive for you to study everything. So you can just take a little, observe, and then you are done. So now let's move to sampling itself. Sampling. So what's sampling? Sampling. So sampling here is defined as the procedure of taking sample from a population. The procedure of taking sample from a population. You know, there are times that if you are cooking, let's say you are cooking stew, for instance, and you are about to conclude and you want to check whether your sauce is right. You know, most times you want to stir. Is that not it? You put in your spoon, or you put in your omorogun, or you put in whatever you need to put in. Your spatula. Just put in anything. If you like, you can put in your hand and then you stir. What do you want to achieve? You want to achieve homogeneity. That's a procedure. You want to be sure that what you have added is evenly distributed. So that's why you need to steer so that they are evenly distributed and then you take your sample. That's a procedure, all right? That's a procedure. You will appreciate that by the time I'm now explaining each of the sampling procedure. So sampling is simply the procedure of taking sample from the population. Now, I'll define sampling frame. Sampling frame. A frame is a list or a map from where sample can be taken. So I want to select accounting students, maybe 20 of them. I want to select 5 at random to represent the faculty in an ICANN competition. So how do I do my selection? I can decide to use the broadsheet. So from the broadsheet, I observe the current performance, maybe in terms of the GPA or the CGPA. From there, I select my students. Or it could be that from that broadsheet, I decided to collect all the names of accounting students and then use some form of raffle draw, and then I do my selection. That broadsheet is my frame. It is a list that I have selected my sample from. So any list or map or any other acceptable material from where sample can be taken is called a sampling frame. Sampling itself is a procedure, okay, that you go through in selecting the sample. Now, this procedure can be of 2 types. We have what we call the probability sampling, and then we also have the non-probability sampling. There are times that you do your selection in such a way that you apply randomness, you apply chance mechanism, you apply probability in your selection. So if you employ any random techniques, just as you have done in your cooking, that you have to stir and stir and stir before you take a sample, the procedure is probability sampling, because you have introduced randomness, you have introduced chance, you have introduced probability. But there are times that you do your selection based on subjectivity. You are subjective. Oh, I want to select them to represent University of Lagos in the next Nuga game. I can't select at random. I will select based on information. How many students are into sporting activity? Who are they? It is from those lists that I do my selection. That selection is not done at random. It is done based on some subjective criteria. That is non-probability sampling. So our sampling can be done in such a way that you employ random techniques, you employ probability, you employ chance mechanism in the selection. That is probability sampling. However, if your selection is done in such a way that you have not brought in any chance mechanism, you have not brought in any probability theory, you have not brought in any random techniques, then what you have is non-probability sampling. So let's look at the 2 types. Then we see how they are employed. So let's look at the probability sampling. Probability sampling. Remember I said that probability sampling employs the use of chance mechanism. It employs the use of random techniques. It employs the use of probability theory selection. So example of probability sampling include the simple random sampling, simple random sampling. We also have the stratified random sampling, stratified random sampling. We have systematic sampling, systematic sampling. And then we also have cluster sampling, cluster sampling. So let's take the first one, which is simple random sampling. Simple random sampling. Ladies and gentlemen, however, if you have any question, just raise your hand and then ask your question. If you need clarification, please do let me know. You are free to call my attention. All right. So, like I said, this is a very simple course, and I'm laying the foundation, and I want you to get it right from day one. So, feel free to express your concern if you have any. All right. So we're looking at simple random sampling. Simple random sampling. Under simple random sampling, all the units are given equal chance of being selected. Under simple random sampling, the probability of selecting any unit is equal to selecting other units. That means all the units are given equal chance of being selected. The probability of selection is equal for all the units. So, I want to promote a particular product, and I have asked people to submit entries, you know. So I want to give out gifts. So I decided to say, oh, if you buy my product, tear up the lead, write your name on the lead, and then submit in a particular spot, in a box, put in a particular spot, and then at the end of the day, there's a caveat that says every entry or all entries have equal chance of being a winner. All entries. What does that mean? It simply means that you are giving all entries equal probability. So you are using simple random sampling to select the winner. So it could also be that, oh, I buy this product, scan the QR code, which automatically capture your details, and then you are qualified for the entry. Every entry have equal chance of being a winner. It's still the same thing. Okay, so I'm giving everybody equal chance of being selected. That is simple random sampling. Under simple random sampling, you give everybody equal chance of being selected. So you can see from the way I've explained it that it's very simple to implement in terms of the advantage. Very, very simple. In fact, it can be very cheap because you don't need any special skill to do the selection. So as long as you have a list of all entries, then you can use raffle draw method, you can use any method, just select at random, and then you have your winner. So simple. So simple in terms of the application, simple in terms of implementation. Even the cost can be very, very easy. However, in terms of the effectiveness, simple random sampling might be disadvantaged, especially when the units have heterogeneous background. Okay, so for example, I have a population that is mixed. I have male, I have female, and I'm giving everybody equal chance, and I want to select 5 students at random. You know, it is possible that I end up selecting only female. It is possible that I also end up selecting only male. So, which means that the background of that population have not been put into consideration at the time of the selection. That's a major disadvantage of simple random sampling, because it gives everybody equal chance. And that means in a population that is not homogeneous, you might not end up getting a population that is, might not end up getting sample that is a representative of that population. So that's a major disadvantage of simple random sampling. And also, for you to effect simple random sampling, you need a frame. There has to be a list of all entries. It is from that list that you will select, because you are saying that you're giving everybody equal chance. So you need to have a list of all entries. So which means that if that list is not available, you won't be able to effect simple random sampling. That's a major disadvantage. Okay? Although you have said that it's simple, in terms of timing, it can be time efficient. In terms of cost, it can be cost effective, blah, blah, blah. But those two major disadvantages, they are key. It doesn't put into consideration the background of the population, and also when there's no list, when there's no frame, you won't be able to execute simple random sampling, right? So that takes us to the next one, which is stratified random sampling. Stratified random sampling. Now, what's the difference? Under the simple random sampling, everybody has equal chance. But there's a problem. When the population is heterogeneous, you have issues. What stratified random sampling says is that, look, if you have identified that the population is heterogeneous, can't you just divide them based on the line of difference, so that I can have female, then I have male? So from the female, I do my random sampling. From the male, I also do my random sampling. I put together what I have should be a better representative of that population. That is simple. That is stratified random sampling. So stratified random sampling is in 2 phases. The first phase is that divide the population into heterogeneous units. You divide them into groups. You call them strata. So you form strata. So each stratum is expected to have homogeneous units, because you have divided them based on your groupings, based on the information that you have about the population. Okay?
Excuse me,
So
sir.
that is yes, I'm listening.
Yes, sir. Please, can you come again with the meaning of stratified random sampling? I didn't get the meaning.
Okay.
Thank you, sir.
So I said stratification requires that you divide your units into groups. Because of the deficiency in the simple random sampling, when the units are heterogeneous, if you apply simple random sampling, you might not get a true representative of that population. Stratified random sampling is saying divide them along the differences. So I now form different groups. Each group is called a stratum. So I can have female group, I have male group. That process is called stratification, dividing the population units into stratum, such that each stratum is made up of units that are homogeneous. Now, after dividing them, you now apply simple random sampling in each of the stratum. So I have list of female students now. From the female student, I do my selection. I can have maybe 3 students. From the male student, I do my selection. Maybe I can have 2 students. I combine them together, I end up getting 5 that I'm interested in. If I had selected the 5 based on simple random, I might end up getting only male or only female. But now that I have divided them into male and female group, I'm assured that my sample will be made up of all major groups in that population. That's the essence of the stratified random sampling. So stratified random sampling is a probability-based method that divides the population unit into homogeneous groups, and then from each group, simple random samples are selected.
Okay.
Some of our colleagues are just making noise. Wow.
Hello, good morning, sir.
Yeah, morning.
Yes, sir. Please, you mentioned sampling frame earlier. I wanted to ask, what's the difference between sampling frame
Yes.
and population size?
Oh, population size is the number of units in the population. So it's a definite figure. 200, 300, 1,005. That's the population size. All right. But a sampling frame is a list. Like your class register sheet. It could be any other material that contains the details of the population. That's a sampling frame. Because I can use that to guide my selection. So a sampling frame is a list or a map. Sometimes I might not be interested in selecting human beings. I'm interested in selecting houses. That means I need map. Is a list or a map or any other aspect. The population size is just a number. How many people are in that population? That's population size. But the list of all the units in that population is in a frame. So, all right, so let's move to the next one. Okay, so let's look at the advantages and disadvantages of stratified sampling. From the way I've explained the procedure, you will agree with me that the outcome of that selection will give a better representative of the population, especially when the population is heterogeneous. So I'm rest assured that my selection is a true representative of the population. I have everybody present in that population. All right, so that is stratification. But when you look at the disadvantages, because I need to apply simple random sampling at the end of the day in each of the stratum, that means I need frames for each of the stratum. So yes, I want to assure representation, but I end up creating more problems because I needed a frame for each of the stratum that I've created. Multiple frames are required, and that makes it more difficult. Even the process of stratification cannot be all the time as simple as I've explained. Oh, male, female. Most times in practice, you might need experts to do the stratification because the 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 division criteria might not be as easy as I've just explained. So you need experts to stratify. That means additional cost. All right. Although you will gain by having a better representation of the population, you will gain from there. But when you look at um, the cost, you weigh the two. A decision has to be made there, especially when you have limited budget. So let's look at systematic sampling. Systematic sampling. There are times that your selection is done in such a way that you select at regular interval. You can select at maybe two steps away. Can select at five steps away. Can select at different steps away. So when you do your selection in such a way that the units are selected at regular interval, that's systematic sampling. So systematic sampling is a probability-based sampling in which samples are selected at regular interval k after the initial random start are excuse me. The initial random start is actually the starting point. So once you identify the starting point, the rest is being selected at regular interval. If, for example, I'm starting at number 1 and I'm to select at 4 interval, that means I'll be adding 4 to my numbers. So if I'm number 1 is part of my sample, I add 4 to 1. That means 5. So number 5 is the next member of the sample. I add 4 to 5, 9. That means candidate number 9 is part of the sample, and that cycle continues. So when you select a regular interval, you are selecting systematically. Systematic sampling, if you look at the procedure, it is simple, it is cheap, and so on. So, but it has a major problem too, the problem of sampling frame, because remember I said you have a starting point. I was starting with number 1, and I said I'm selecting at regular interval 4. Number 1 simply means I have a frame that I'm using. It is from that frame that I identify candidate on number 1. I add 4 to it, candidate on number 5 is added. Candidate on number 9 is added. That means there is a frame. If that frame is not available, you will not be able to execute systematic sampling. All right? So that sampling frame is a major problem with probability sampling because you will always need it. If you don't have a list somewhere, if there is no list somewhere, you will not be able to execute probability sampling. All right? So let's look at cluster sampling. Cluster sampling. So under cluster sampling, the selection is not done by selecting the units. You select clusters. The first phase of cluster sampling is that the units are grouped together to form clusters. At the end of the day, if you end up getting like maybe 7 clusters, then it is clusters that are selected at random, not the units. Unlike the stratified sampling, where population are divided into strata, and then from each stratum, we apply simple random sampling. But under cluster sampling, population units are grouped to form clusters based on geographical proximities. And then clusters are selected at random. It is the cluster that we select in this case. Then the units of the selected clusters constitute our sample. This is mostly used in medical research, where areas are grouped together to form clusters. Because we all know that resources are always limited. So if you are conducting studies and you don't have enough resources, you will do your distribution in such a way that you touch as many areas as possible. So if you group the population units to form clusters and then you select at random, Abule Oja, Unilag, Akoka, they can form clusters because they are very close in terms of proximity. Mushin, Oshodi, Mafoluku can form clusters. That can be because of proximity. Agege and Akwaja can form clusters based on proximity. So if you have formed all these clusters here and there, and we all know that the units in each of those clusters are heterogeneous. That means you have almost all characteristics of the population inside each of the clusters. So if you select two clusters at random, all the units in the selected clusters will now represent your sample. You are likely to have a better representation of the population. Okay, so that's whatever you compute, you will end up estimate that is efficient and estimate that is likely to be unbiased. However, you can see the way I'm explaining it, that it is not as straightforward as simple random sampling. It is not even as easy as systematic sampling, nor as easy as stratified sampling. So it requires some high level of technicality, and that might make it to be difficult in terms of implementation. Although in terms of efficiency, unbiasedness, or reliability, estimates from this type of sampling procedure, they are very, very good. But what of the cost, and some other difficulty in its implementation? So these are the types of probability sampling that we have looked at. Now let's see non-probability sampling. So let's have a look at non-probability sampling. Non-probability sampling. However,
Yes,
please, so you should always call my attention. Yes, someone is talking.
Good
sir,
morning,
you
sir.
mentioned
I wanted
Yes,
to ask.
that lady first. That lady first. Your
Okay.
voice is thicker.
okay.
Let her talk, and then you.
Sir, please, you
Yes,
mentioned two types of stratified random sampling.
stratified.
Yes,
I
I didn't get the
said
second.
it's in two phases. But the
Okay,
first phase you divide the population into
okay.
strata, and then from each of the stratum, that's the second phase now. From each of the stratum, you select simple random sample. So what's your question?
So I wanted to ask. You said simple random sampling when all
Yes,
entries are given the
equal
chance.
chance.
I want to
Yes.
ask if possibility of singular units having multiple entries. That is
Okay, so that what if you have multiple entries?
from a single.
Okay. So in that case, weights have to be applied because the units don't have equal weight now. Because some units might be maybe 3, especially if you have 3 entries. You know, yours will now be 3. If there's another entry, another person that has 5 entries. So in that case, the weight will have to be applied to bring it to ensure equality. So that can also be can be easily taken care of. So the weighting you
Hello,
put
sir.
into consideration when you're selecting. Yes.
Sir.
Sir, my network went off. I just get it, but I didn't understand the explanation on
Don't worry.
probability.
You know, I will share the recorded session. And then by the time I'm rounding up, I will start all over again just to do a recap of what we have done for today. I think that would address that concern. All right?
Excuse me, sir.
Yes.
Good morning, sir.
Good morning. Yeah, I'm listening.
Yes, sir. Oh, shit! Oh!
Go ahead. Go ahead. Go ahead. We are listening. All right. If you're having difficulty, you can type. So I will read and then get your questions if you have some technical issues. Okay, so let's look at probability sampling. Remember, I said that you have 2 types of sampling. You have one that employs random techniques, employs chance mechanism, employs probability theory in its selection. That is probability-based sampling. And then the other one, do not employ chance mechanism. Do not employ random techniques or probability theory in selection. That is non-probability sampling. So you're not bringing anything chance here. You're not bringing anything random. You're not bringing anything probability. You are using information, all right, to guide your sampling. So non-probability sampling, they are sampling procedures that do not employ the use of chance mechanism, that do not employ the use of random techniques, that do not employ the use of probability theory in its selection. So examples include the convenience sampling, purposive sampling, quota sampling, snowball sampling. Sometimes it is known as network sampling. So I'll start with convenience sampling. Now, convenience sampling is a non-probability based sampling, okay, in which the population, the sample that's selected from where the researcher has access. So it is accessibility that determines convenience sampling. So when you have access, you select because you have access. That is convenience sampling. Okay? You are doing a term paper, and the term paper requires that you administer questionnaires on bankers. Now, it is very, very difficult for you to walk up to any bank and start administering questionnaire. The security guy will not even allow you in. But because your mom, your dad, your brother, or your friend works in a bank, and then as a result, you have access to administer those questionnaires. That procedure has no random chance, has no chance mechanism, has no probability in its selection. You did the selection because you have access to that population. Please, you guys should just assist by muting yourself. I might be forced to eject some of us. So let me just hope that you guys will be mature enough to do the right thing. All right. So when you do your selection because you have access, okay, that's convenience sampling. So selection is done in such a way that there's access, okay, to the population. It's accessibility that determines convenience sampling. So because I know that I'll be having a VH310 class today between 8:30 and 10 a.m. and I decided to send a link through your class governor to you that, look, please fill in, go through that link, supply details, I'm carrying out a study and so on. So I'm taking advantage of the access that I have, to you guys. So that method of selection is convenience sampling. So convenience, I'm doing my selection because I have access to you. So when you select from a population from where you have access to, that is convenience sampling. I have not applied any chance. I have not applied any random technique. I have not applied any probability in it. I only selected because I have access. That's convenience sampling. So the next one is purposive sampling. Now, purposive sampling is also a non-probability based sampling. But this time around, it is based on information. I select based on information. Under convenience, I select based on what? Access. But under purposive, I'm selecting based on information. So I'm carrying out a study on students that are into sporting activities or students that are tech savvy, students that are very good with social media and so on. So, but I have information that, look, a particular lady XYZ, particular guy ABC can, is also good in it. Based on that information, then I'll go and select that lady or select that guy to be part of my sample. Because I select based on information. I cannot select at random because not all students are good with social media. Not all students are good with the use of computers and so on. So I cannot select at random. Okay, I cannot even use a list, your class broadsheet to do the selection because the broadsheet is not giving me detail about who and who are in that space. So I can't do the selection. I will select based on information. Remember, for convenience, I select based on access. I have access to that population. That's why I'm selecting from there. Under purposive, I will select based on the information. Look at the competition that you guys normally have during your second semester. You want to have Miss or Mr. Accounting, Miss FMS, Mr. FMS. Will you select student at random to go and represent your department? No. You will select only students that meet the requirements, students that are likely to win, that competition for your class. So you select based on information. There's a chess competition, and I want a finance student to go and represent the faculty. Will I select at random? No, I only select students that I know, I have information about, that are very good with chess. So that's purposive sampling. When you select based on information. Remember, for convenience, you select based on accessibility. For purposive, you select based on information. Now let's look at quota sampling. Quota sampling. You know, the Nigerian politics is, in fact, our system is based on quota. You want everybody to be represented. All right. So it is similar to stratified sampling, but here you're not employing any simple random sampling to select from each of the stratum. So under quota sampling, you are selecting to ensure that the major groups in the population are represented. You give everybody quota. And look, okay, I have 5 groups here. Okay, everybody give me one candidate so that we have 5 to represent us. So I want to ensure that all the groups are represented, but I'm not applying any chance mechanism. I'm not selecting at random. I just want nomination so that all groups are represented. So quota sampling is a non-probability sampling. Quota sampling is a non-probability sampling in which the samples are selected in such a way that all major groups in the population are represented. It's a non-probability sampling in which samples are selected in such a way that all major groups in the population are represented. So you can see that for convenience, for POSI, for quota, we are not using any random techniques. We are not employing any chance mechanism. We are not putting in any probability knowledge, any probability theory in our selection. We select based on some peculiarity. The first one, because I have access to that population, I will go and do my selection. The second one, because I have information about that population, I'll go and do my selection. The third one, I want to ensure that everybody is in there, but I don't want to do any randomness at all. Once a group is there, I am okay with it. That is quota sampling. The next one is snowballing, snowball sampling, snowball sampling.
Sir, please, I have a question.
Yeah, go ahead.
Yes, sir. Which one is based on peculiarity?
All of them. All of them.
Sir?
The first one is, I said all of them. The first one is, what's the peculiarity here? Access, accessibility. That is convenience, accessibility. That's the peculiarity there. The second one is information. Oh, I have information. I do my selection. The third one, the groupings. Major group in the population, everybody, once I have one of you there, I'm okay. That's the peculiarity there. So all of them. So I do here, they're not selecting using any chance mechanism, and you're just selecting based on some well-defined peculiarity. Okay, access, information, or groupings. And then the last one.
Excuse me, sir. Are we like the purposive sampling? Yes. Is it just based on information? I heard somewhere that is judgmental, like another name for it is judgmental.
Yes, but how will you select? You select because you have access. Yeah, is that access that is the key there? Forget about different names for it. You select because you have access to it. You have access to the group.
Okay, sir.
So the next one is snowball sampling. Sometimes this is called network sampling. So if I may ask now, how many of those boys are engaged in substance? How will you know? So if I ask your class governor how many students are engaged in substance, they wouldn't know because it's not written on faces. Or if I ask How many of my students are engaged in night crawling? It's difficult to know. I may also ask, how many students are into skit production and so on? It's difficult to know because there's no list anywhere. Okay, so I can use the principle of birds of the same feather flocks together. That means I can use the unit to generate. So once I get one, and that one is well, I give that person a lot of incentive, I assure some level of trust and some other understanding. That can lead me to other members. And then from those other members, I can also get other members. And from those other members, from other members, I can generate and so on. Then I have my network. That's snowballing. So when you use a unit to generate other members, that is network sampling or snowball sampling. So you can see that they often use it in network marketing, where they give some incentive that look, if you introduce us to 5 other customers, you'll be rewarded with ABC. And those other customers that have been introduced to you, you also ask them to also lead you to 5 each, and then you see the network keep growing and growing and growing. So when you use a member of the population to generate, okay, your sample, what you are doing is snowballing. What you are doing is snowball sampling, right? So that's what snowballing or network sampling is all about. This is mostly used for hidden population. How many billionaires do we have in Nigeria? There's no list of billionaires, but you know that billionaires are friends of billionaires. That means if you have one billionaire, that one billionaire can lead you to other ones, and then you have an idea of the numbers. So how many students are into skit? You might be surprised that those that are in skit production are friends to each other. So once you have one, that one will lead you to other members, and then you generate. So I think we should stop at that for today, so that we can have time to do other things. So what have we done? We started by basic definition. We started with population, remember? So we define population as a collection of well-defined units in the target universe. So, and I cautioned us that population is different from population size. So population size is the number of the units in that population, while the collection itself is population. So, and then we also define sample, that a sample is a fractional part of a population. That small part, that subset of a population is called our sample. And I said the essence of sampling is to estimate the unknown population parameter. Because why do you have to take sample? You're taking sample because you don't have full detail of that population. That's the essence of taking the sample. But if you have detail of the population, then there's no need. So you take the sample so that you can observe that sample, and then you generalize on the population. So what do you do with your sample? You estimate, okay, the population parameter. And then we define a parameter. We said the parameter is a function of all the units in the population. A parameter is a function of all the units in the population. As I said, the population mean, the population variance, the population standard deviation, and so on. They are all parameter. Then we define statistic. We said a statistic is a function of the unit in a sample. So you can have sample mean, can have sample variance, sample standard deviation, and so on. And then we also discussed estimation as the procedure for estimating the value of the population parameter. So we said this estimation could be point, and it can be interval. When it is point, it will lead you to a single value. When it's an interval, it will lead you to a range of values, such that you have the minimum possible and the maximum possible. Then the value that you arrive at is called the estimate. So an estimate is the value for the population parameter. So if your value, if you have one single value as the computed value point, if you have a range, you have interval. So the formula that is being used is called the estimator. Then we define sampling. So sampling is a procedure of taking sampling from the population. And then we have a sampling frame, which is a list or a map or any other acceptable material from which sample can be taken. And then we discuss the different types of sampling. And we have two major groupings. We have probability-based sampling and non-probability-based sampling. So we say probability-based will employ the use of chance mechanism, probability theory, and random techniques. While non-probability-based is not employing any of those chance, random, or probability theory in its selection. And then we looked at different types of probability sampling. We looked at simple random sampling, we looked at stratified random sampling, cluster sampling, systematic sampling, and then we discussed each one of them. So the same, we also discussed the non-probability sampling, the convenience, the purposive, the filter, and snowball sampling. So next week, we will look at errors in sampling, and then we also do sampling distribution. So on that note, I will close the class for today, and then see you next.
Sorry, sir. Can you please explain snowball sampling?
Can I please explain what? Snowball.
Snowball sampling. Yes, sir.
Yeah, I said snowball sampling is a non-probability sampling that involves the use of a member of the population to generate your sample. That's snowball sampling. You use one to generate other members of the sample. That's what snowball sampling.
Sir, good morning.
Yes, good morning. I'm
Sir,
listening
please,
to you.
I didn't get the definition of systematic sampling.
Okay. I said
Yes,
systematic sampling is a non-probability based sampling that requires.
It's under the.
It's under probability based sampling.
Yes, sir.
Yes, a probability based sampling that requires the selection of your sample at regular interval after the initial random start. Can I explain? I said once you start from a point, then you start selecting at regular interval. That regular interval, I give the example of me starting at point 1, and then I'm selecting at regular interval 4. So that means candidate number 1 is there. I'll add 4 to it. It gives me 5. That means the second person I'm selecting is on number 5. The third person, if I add 5 to it, 4 to it, gives me 9. The third person is on serial number 9, and so on. So I'll give you more material.
Thank you, sir.
Please check the links that I shared earlier. So please follow those links and then access them. But if you have difficulty in the next class, please call my attention to it. So I'll see you next week.
Sir.
Yeah.
Excuse me, sir.
Yeah, I'm listening.
Thank you so much, sir. One of the links, sir, has stopped receiving responses.
One of the
links you sent to us has stopped receiving responses.
It stopped.
Receiving responses. They link to a doc file.
Oh, no, that one is your assignment now. I've not opened it. Don't worry. That one is an assignment.
Thank you,
when
sir.
it will be open, I will let
get...
you know. But I shared a video. Did you see it? I shared a video. Did you see the video?
Yes, sir. Yes, sir. Yes, sir.
All right.
Yes,
Then, okay. I shared a textbook last session. You still have it, right? In Ebia 220.
Is it the statistics for economics or what?
Yes.
Okay, so I want to confirm how we get the recording to the class, sir, for those who were not there.
How will they?
I will get the recording for the class, sir. For those who were not there.
We'll get it. Well, once it's ready, I'm recording in the cloud. Once it's ready, I'll just share the link.
Thank you very
Sir,
much.
please, I have a question.
Yeah, ask the question.
Yes, please. Is there a difference between sampling and sampling technique?
They are the same. Sampling is the procedure, just general definition of sampling. The technique now you are being specific, right? So simple, random, stratified, they are all techniques of sampling.
Okay, all right. And for quota sampling, he said they are selecting to try to ensure that the major groups
Are a part of the sample.
Hey girl, you do too much.
How
do they select these major groups?
Oh, okay.
Yeah,
you're not. It could be by recommendation. It could be it could be by the use of a rule of thumb. It could be anything, as long as that group is being represented. It could also be first come first serve basis. It could be you, as long as you're not using any random techniques. That selection could be with any method. So what concerns you there is just to make sure that the group is there. Yes, I'm listening.
Yes, sir, please, can you please differentiate between strata and stratum?
Oh, one is plural, one is singular.
I'm confused. Okay.
Stratum is singular. Strata is plural.
Okay, thank you, sir.
Right.
Thank you very much.
Okay. So, okay, you guys, I'll see you next time. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye, sir.